Hi guys, welcome to today's video. So today I'm going to introduce the 4 pillars of object-oriented programming. So what is a class and what is an object? A class is a blueprint for creating objects. An object represents a specific instance of a class. So you can think of a class as a recipe, an object as the food that is created from this specific recipe. So there are 4 pillars of object-oriented programming: abstractions, encapsulations, inheritance, and polymorphism. And let's take a closer look at each of them. So abstraction is the idea of simplifying complex systems by focusing on the essential characteristics and behavior while hiding unnecessary details. So it is the idea that we only need to know the specific method name that can execute the specific actions that we want to perform, and we really don't need to know about the underlying implementation of this specific method. Here is a code snippet of abstraction. Here we have a car class with some attributes and methods. In the main class, we want to start the engine of the car object, so we simply just call the start engine method right here. And notice that to do what we really want to do, we simply just calling the specific method without the need to know the underlying details of the method itself. And that is the idea of abstraction. So encapsulation is bundling data, which are the attributes, and the methods, which are the functions that operate on the data within a single unit and restrict access to some of the object's components. So encapsulation is very important because it protects the data integrity. This is because oftentimes we wouldn't want users to be able to directly modify the attributes of the objects, since it could potentially damage the data or deletion of the data of the object itself. So to grant access to get certain attributes or delete certain attributes, we can actually create getters and setter methods. So here we have a bank account class that has private attributes, balance, and account number. And we have a withdrawn and deposit method that updates our balance value. And notice that within these two methods, we check for the values of the amount first before we did any changes to our balance value. This is extremely important because, for example, if we didn't have this check-in condition and the amount is greater than our balance, then this would result in a negative balance value at the end, which is something that we really don't want. Hence, by having these setters, it really allows us to be able to check for specific conditions and ensuring the integrity of our data. And in addition, notice that there is no setters for the account number. So this is protected from being overwritten. And again, we also have two getters method that allows the users to be able to view the balance value and the account number value. Hence, using encapsulations, it really ensures the data integrity and grants only restricted access for users to access specific data. So inheritance is the mechanism that allows a new class to inherit properties and methods from an existing class, promoting code reuse. So it really allows us to be able to reuse the code from another class. So here is a code snippet for inheritance. We have an animal parent class and a dog child class. And we are able to inherit the attributes name and species from the parent class. as we call the supered method over here. And also, we are able to also add that additional attributes for this specific child class. Notice that we have a describe method in the parent class here. We also have the describe method in the child class here. So child class, we can also override methods that exists in the parent class. So for example, when we declare a dog object and we call the describe method, it's going to first look into the child class first, and if it finds a describe method, it's going to call that specific method. Whereas if we couldn't find the describe method, it's going to look into the animal class and call it this described method. An example of this is that notice that in the parent class we have a make sound method, but in the child class we don't have a make sound method. So if a dog object calls a make sound method, it's actually going to execute this make sound method in the parent class. So this is the idea of inheritance. So polymorphism is the ability for different classes to be treated as instances of the same class through a common interface, allowing for method overriding. So here we have a really fun code snippet that demonstrates the idea of polymorphisms. We have a chip parent class and and 3 different child classes. And let me just tell you, honestly, Popcorner is the best chip ever. Well, that's kind of off topic. Back to the slides. So here in the main method, right? Let's look closely. We declare a chips array with a Popcorner, objects, Doritos, and Lay's objects. So we iterate this array and perform specific actions that we want. So we simply called print chips.getDescriptions method for each iterations. And notice that we do have a getDescription method here in the parent class, but for all of the child class, we have override that getDescription method. So actually, as we are going through this list and during runtime, the program is going to look into this chips specifically, and it's going to determine, oh, this is a Popcorner objects. So it's simply going to look into the Popcorner class, and it found this getDescription method, so it's going to execute this specific getDescription method. And again, if the program cannot find this method, it will then look into the parent class and call this method instead. And here is kind of the output. As you can see, so we have a Popcorner class as our first element. So this string actually got printed out, right? So because here we said returned self.size popcorners. So this method actually get executed. And the second object's Doritos, right? So we get the Doritos here printed. So we actually call this method over here. And likewise, the third object is a Lay's object. So again, this method got executed. Here is the idea of polymorphism, that we're able to call specific methods that we want during runtime for classes that have the same parent class. So here is kind of a short summary that kind of summarizes the uses of the 4 different pillars of OOP. Abstraction simplifies the systems. Encapsulations protect data integrity. Inheritance increase code reusability. Polymorphism implements a common interface for different types. So, which pillar of OOP is your favorite concept? Comment down below, and thank you guys so much for watching this video. I hope you guys learned something, and I'll see you next time. Bye!